Next 2 days, we're going to spend time, and this is not your notes. I want to just review the tree real quick we did on the first day of parallelograms. Today, we're going to take a look at the rectangle and also at the same time the rhombus. Today will be the properties in algebra. Tomorrow will be proofs with each of them. I'm showing you the tree again because I want to remind you guys why we place the rectangle and the rhombus under the parallelogram. How many properties did the parallelogram have? Oh boy. 5, right? They had 5 properties. All 5 still apply to the rectangle and rhombus. Diagonals bisect each other. Both have. And I'm going to really make a point of this today because what happens in your brain today is going to be this. We're going to start 2 new figures, so that means new properties. No. You still have all the parallelogram properties. They still exist here. So please remember that. So let's start out today with the rectangle. I listed all the properties out to you in the box. Hey, anybody notice the first 5 properties here? Look familiar? Go ahead, read through them. Those first 5 properties look familiar at all? What are they? Opposite sides parallel, opposite sides congruent, opposite angles congruent. This is what? Yeah, I'm going to keep harping on this. Just because it's a new figure, the parallelogram properties still apply. All right, they still apply. Here's where it's going to get tougher, though. Now you have a couple extra theorems or properties that only go to the rectangle. They don't go to the rhombus and they don't go to the parallelogram. They only go to the rectangle. And here they are. I think this first property you knew already. In a rectangle, you have 4 right angles. Right? All angles are equal. They're all right angles. All right? Is that part of a parallelogram? No. And it's not going to be part of a rhombus property either. Only for a rectangle are all the angles right angles. Next, diagonals are congruent. The diagonals are the same length. The same length. What else do they also do? They're congruent and they also what? Why do they bisect each other? A rectangle is a parallelogram. So here's where I'm going to challenge you right now, above average kids. If BD and AC are the same length and they cut each other in half, what should I know about each of these 4 segments that's created? So BD and AC both equal 10. They cut each other in half. What's each little segment now? What's the length? So what are you telling me about each little segment now? They're all congruent. Everyone see that? They're all congruent. And this leads me to, and you're going to write this down right now, a 4th property of a rectangle. Everyone see the 4 triangles that are formed? What type are they? Thank you. Diagonals form 4 isosceles triangles. That's a property of a rectangle I'd like you to remember. Why would I need that, though? Who cares? Here's why. Let's take this isosceles triangle right here. What's across from these congruent sides? Oh, so that's why. So those are equal, and we could go around. All right, that's why it's good to know that there's 4 isosceles triangles in a rectangle because the angles across are equal. All right, any questions on the rectangle? Go ahead, Romeo.
Does that mean that the 2 opposite triangles are congruent?
These 2 congruent and these 2, yes, but not all 4.
Yeah.
Not all 4, correct. Yep, not all 4. Any questions on the rectangle? And I told you there was a second figure today, which is the rhombus. Again, first 5 properties of a rhombus are also what? Same parallelogram. Don't forget that. Everything we've been talking about the last 3 class days, the rhombus and rectangle have. Oh, you will.
You won't forget the fumble.
Okay, that's a better adjustment. All right, so properties of a rhombus that the parallelogram and rectangle do not have. Remember a rectangle, all angles are equal? Rhombus, all sides congruent in a rhombus. All sides congruent in a rhombus. Not in a rectangle, but in a rhombus. The diagonals now. The diagonals of a rhombus. Go ahead, read property number 3 there. Diagonals of a rhombus bisect the angles they're drawn to. So everyone see this angle right here? Bisect it. This angle right here? Bisect it. Real quick, why am I allowed to just put one arc mark here, meaning all 4 of those are equal? How do I know all 4 are equal there? Emma? Oh, it's a parallelogram. Opposite angles are equal. So if I cut those equals in half, they're all equal. And then finally, the last property of a diagonal, they are? So what do they form then? Diagonals form right angles because they're perpendicular. All right? Anything, because I'm basically turning it over to you and your group right now. In a little bit anyway. Not in this second, but in a minute. All right, I'm not doing these for you. If you're going to struggle, you're going to struggle together, and we're going to get through it. All right, directions first. I am letting you know, and it's already in the directions. Those first 4 figures are parallelograms. You know that already they're parallelograms, I'm telling you. And then I put a little extra markings on them. Give me a better name now than parallelogram. So look at number 1. That's a parallelogram, and everyone see the right angle symbol in there? So what did I just create now? A parallelogram with a right angle makes it into a? That is a rectangle. Now, I don't need all 4 right angles. Listen, you don't need all 4. You just need one right angle in a parallelogram that makes it into a rectangle. So you and your group right now, using parallelogram properties, rectangle properties, geometry facts, you're going to come up with angles 1, 2, 3, and 4 right now, knowing that's 18 degrees. It's okay to find a blank angle. It may lead to a numbered angle. Discuss it in your group. Let's go, let's go, let's go. Discuss it, discuss it. 18, give me an angle you're confident in. Angle?
Angle 4 is 144.
Angle 4, 144. All right, we went right with angle 4. All right, how did we get to 144 without giving away the other angles? How about this? If that's 18, this angle's got to be, what was that, 72? This angle, because it forms a right angle. It's a rectangle. Has right angles. This triangle's isosceles, so this is 72. Good so far? And then you could go to the middle angle, the third and final angle, which would be what, 30? What is that, 144? 36? And 36 and 4 are supplementary because they're linear pairs. I guess that's the best way to go about it, to find angle 4. So that's 144. Other angles now. Other angles. 23, another angle?
Angle 3 is
18. Pretty easy here. That's probably would have been the first angle I would have found. It's alternate interior with the 18 they gave you. And you have parallel lines because it's a parallelogram. All right, now we're down to 2 or 1 now. 19. 1 is 72 degrees. Again, if that's 18, the top triangle is isosceles. So that's 18, making this 72 because it forms a right angle. And then finally, how about angle 2? 3, angle 2?
Angle 2 is
36. Again, 72, 72. Isosceles 36 to get to 180. Any issues? Okay, let's keep trucking. Number 2. We already knew it was a parallelogram from the directions. Now you know all 4 sides are equal. A better name? Rhombus. And I'll let you guys know this is a very, very easy problem if you just know a couple properties. Very easy if you know a couple properties of a rhombus. Go ahead. Talk to each other. Very easy if you read your properties.
One's 50.
Okay, let's get it started. Give me an angle you're confident in. 10. 3 is 90. It's a property. Diagonals are perpendicular. They form right angles. That's it. That's it. Diagonals are perpendicular. So you get 90 degrees there. Another angle, 9.
Angle 1 is 59.
Angle 1 is 59. It's alternate interior with the 59 I gave you. All right, no issues yet. 17, another angle.
Angle 4 is 59.
Angle 4 is 59. Hey, that's a property. Diagonals bisect the angles. And then I'm only looking for angle 2, which is the same property that has been used already. 22.
90 degrees.
Diagonals perpendicular. Done. Any issues? Okay, now this one's going to be a challenge here. Number 3, I didn't put any markings on it. And don't tell me it looks like this. That looks like doesn't cut it in this class. It's got to be mathematically proven here. Looks like doesn't work here. So how am I going to figure out a better name here? Well, you already know it's a parallelogram, right? So if this is 30 right here, what other angle's got to be 30? 2, because they're alternate interior. Put it together with the 60. What do you got here? A 90 degree, a right angle. Now it's a what? There you go. And hold on, we're going to do number 4 too. Number 4, parallelogram, all 4 sides congruent makes it A. All right, you guys find the missing angles now. Go ahead, 3 and 4, so we don't have to stop in between. Isosceles triangles and the rectangle.
6 is 360.
Probably. Is there a
4 oh, that's great. So
4 is 4 and the rhombus is 1. Oh wait, doesn't this do isosceles
so what's 90 divided by 2? 1 and 2 are 45. And 3 is 60.
There's another one.
The 68 or the 45?
No, the 68. You just put 45 because it's a triangle. Yeah.
So 68.
Because if it was 68, then 2 would also be 68. Like 5.
Number 3.
But I don't. This is 3. This is 68 and then 3. And one would be 22.
Angle 1, 2, and 3, and 4. Okay, problem 3. Name an angle for me. You want 15. Name an angle. 15. Problem 3. Number 1 is 60. Yep, forms a right angle with the 30 next to it. Let's keep going. 11. 1.
Oh, 2 is 30.
2 is 30. We already had that. That was too easy, George, for you. 6. 5. 12.
3 is 60.
3 is 60. Yep, isosceles triangle. And angle 4. Finish this up. 23. 30. Anybody want to ask any questions on your rectangle? And B. 1, 2, 3, 4 again. Oh, 15. Angle 1, 2, 3, or 4. 22 degrees. Yep. 22. 13. Another angle. 13.
Angle 3 is 68.
68. Diagonals bisect the angles. Yep. 68. Oh boy. 3. Another one.
Angle 4 is 90.
Diagonals perpendicular. And angle 2. 7. 68. Diagonals bisect each other. All right. Good. Knowing your properties. We just did a ton of work on angles, huh? Now we got to go actual lengths now, not angle measures. Hey, got a rectangle. HIJK. Quick review. How do I label it correctly? Clockwise or counterclockwise. Don't jump diagonally, right? That'll throw off where your diagonal should be. HIJK. Clockwise or counterclockwise. Don't jump diagonally. HJ. What is HJ? 3x plus 5, but what is it? A diagonal. What's IK? Diagonal. In a rectangle, what do we know about them? They're congruent. Look at that. Pretty easy problem when I know the property. Yep. 3x plus 5 equals 5x minus 9. Diagonals are congruent in a rectangle.
Do you want the answer?
No. I'd like your classmates to perform their work first. Maybe your number will come up, huh? Wouldn't we all be so lucky? When you're ready, let me know what x equals. Oh, so close. You could just sniff it, Via. So close. George, let's go. Redemption. 7. That was 1/3 of the problem, though. It said find x. Now find each diagonal. So plug it back in. And my hope is that each diagonal length is the same, because that's what the property says. So what were the diagonal lengths when you're ready? 9? When you're ready. Here we go. Any questions before we get to the tough one to end it? Now we got a rhombus. One diagonal, GI is 8, the other is 6. Find the length of a side. Before we get going, will it matter what side I find on that rhombus? Will it matter? Why not? Why won't it matter what side I find? Why doesn't it matter what side I find here? They're all congruent in a rhombus, so it does not matter the side you find. All right, well, we're talking about a rhombus here. Can anybody put any more detail on my diagram, maybe? I got GI diagonal 8 and another diagonal 6. It's a rhombus. I'm not going to feed this to you. You're going to earn this. What else can I put on my diagram here? Use your properties. Look at the properties. What else can I put on the diagram here? If GI is 8 and FH is 6. It's got to be something with the diagonals. One thing only, Zach, I can put on here. So GI is 8. They bisect each other. Everyone all right with 4 and 4? And what else? What can I put on the other two? 3 and 3, right? All right, we're getting somewhere. Still got to find a side, though. What else do you know about the diagonals? Romeo? They were perpendicular, so I have a right angle. Oh! Looks like I got a right triangle here. How many sides do we know in this right triangle? 2. And you need to find the third side. I think we've used something quite a bit this year, where if I have 2 sides of a right triangle and I need to know the third, or maybe we haven't done it enough. A squared plus b squared equals Pythagorean Theorem. If I know 2 sides of a right triangle, I can find the third using Pythagorean Theorem. Where's the 3 and the 4 going to go? A and B, because I'm looking for C, the hypotenuse. Good. So here you go. 3 squared plus 4 squared equals C squared. 9 and 16 equals C squared. 25 equals C squared. So what's the side length? 5. Yep. Take the square root of each side. 5. You yourself, somebody in your group, have an answer key out on your Chromebook, and let's get going with the homework. 15 minutes I'm giving you here. 15. Let's roll. Talk it over, each question over with your group as you move along.